Hello, 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 chickadees, and welcome to Tuesday's lesson. I'm not sure how it will go today in terms of numbers because I know that some of the year sixes are back at school and some schools are doing year fives. So it's brilliant to see all of you who have joined us. And if you know a sibling or somebody is at school, then they can absolutely watch the lesson on YouTube and catch up. So hello, are you an old friend or a new friend? Let me know how you're doing today. Are you an old friend or a new friend? Have you just joined us today or have you been with us before? Old friend or new friend, let me know who you are. And while you are doing that, I can tell you that we have been very to infinity, very, hello, old friend, busy because Bright Idea Education are ready. Oh, since forever. Yay. Hello. How old are you? There's a little bit of a cheeky question. I have been here since the start of the lesson, so it's lesson 14 today, so I must be 14. Hello, new friend. Welcome. So Bright Idea have been very busy to infinity, as I said, because next Monday we are launching our new app. Now, is there anybody on the group who was part of our group testing? Anybody really old friend who was actually part of the schools that we came in to test our demo app with? On the earlier lesson, we did have somebody who was from one of our testing schools. So we tested an app, we got loads of feedback, and we have used all of that feedback from lesson one. Kind of new, okay. And we've used all that feedback to make the app even better. So on Monday, we are launching a new app. It's all free. You will not know whether you are gaming or learning because it will be really hard to tell. So please make sure that your parents and carers have got all the social media so that they can download that app on Monday and you can actually get started using that app. It's brilliant. Place value, add in, it's got spaceships. Oh, not supposed to tell you anything more about it. You have to wait and see, but it's very exciting. I have played it loads and loads of times and I still find it exciting, especially the bit when, sorry, not allowed to tell you. So make sure you're all tuned into that social media. So while we have been waiting, you hopefully have been looking at this brain teaser. Now, Mo is comparing two fractions. She is comparing 3/7 and 6/11. Okay, Mo is a he. He wants to find a common denominator. Do you think this is the most effective way? Do you think this is the most effective way to find out whether 6/11 is more, less, or equal to 3/7? Do you think finding a common denominator is the most effective way? We can't wait for it to be out either. Do you think it's the most effective way to find the common denominators? Are we allowed to work together? Yes, you can ask somebody else, absolutely, if they have an idea. Oh, on the app, are we allowed to work together? Now, are we allowed in this lesson, or are we allowed on the app to work together? Which one? I'm not sure where that question's aimed. If it's aimed at the lesson, absolutely, you can use somebody else's idea and share ideas. If it's aimed at the app, not yet is the answer, okay? Not yet. The first app, it's a work alone, but we have got planned in the future that there will be online working together as well. Okay, so what is it more effective? That's what we want to know, not straight away the answer. Is it the most effective thing? Normally, if the fractions are not from the same family, we would find a common denominator. Is it the most effective way for this question? Now we know because 7 and 11 are prime numbers, so they're not going to be multiples. They're not going to be in the same multiple family. So we're going to have to go straight to 77. We're going to have to multiply them. And then we're going to have to do, what did we have to do to 7 to make it 77? Okay, times that by 3. There is a simpler way. There is a simpler way. It's not as effective as what? Not as effective as what? Finding the denominators. Now, I think I touched on this last lesson, and I don't think anybody had ever used this method before. We could look at making the numerators the same. What would we have to do to 3/7 for it to have the same numerator as 6/11? What would we have to do? What would we have to do to 3/7 to make it have the same numerator as 6/11? What would we have to do? What would we have to do? What would we have to do? What do we have to do? Okay, we could double, we could times that by 2. If we times the top by 2, we also have to do the same to the bottom. Remember, we have to do exactly the same, otherwise we change the relationship. Okay, so we could say 6 14ths. Okay, we've done the same to the top as we've done to the bottom. Now that we have the same numerators, let's have a look now. Now that we have the same numerators, we have 6 14ths and 6 11ths. Okay, 6 14ths and 6 11ths. So that looks like a 0 now. Let me move that over a little bit to make it a bit clearer. We have 6 14ths and we have 6 11ths. Now, knowing that there are 6 of each one, which is the larger fraction, 14 or 11? Which is the larger fraction? Would you rather have 6 11ths of a pi or 6 14ths of a pi? Which is the larger fraction? Yes. So it goes like that. So although we know that when we are comparing fractions, we need to make the denominators, sometimes we can make the numerators the same and then look at which are the smaller fractions. Let's just stick with that for a moment, because this bigger, smaller fractions can cause problems for people. So let's just jump out of that problem for a moment, and we'll come back to it in a minute to look at the other one. Let's just look at this bigger and smaller. Let's just jump down here and look at these lovely, lovely cakes. Look at these lovely, lovely cakes. Yummy, 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 yummy. I wish they were in my, what? Finish the yummy, yummy, yummy. I wish they were in my, in my tasty. So the first one shows what? That is 3 what? Tummy, exactly. That is 3 what? This has been split into, that cake is 3, they've been split into thirds, so that is 3 thirds. Okay. What's this one? What's this one? What's this one? This is, this next tasty cake, which makes me really hungry, is 6 sixths. What's this next one? What's this next one? What's this next one being split into? What's this next one being split into? This one is 9 ninths. Okay. So if I said to you now, can you order these fractions in ascending order, with the smallest one first to the biggest? Ascending is like ascending from the bottom to the top of a mountain. Can you put those fractions in ascending order for me, please? Ascending order from the smallest fraction to the biggest fraction. Okay, smallest to the biggest. The smallest fraction to the largest fraction. Okay, smallest to the largest. And when you think small fraction, you think, not a very big piece of cake. When you think big fraction, you think, nice bit of cake. So the smallest fraction is 1/9. The next fraction is 1/6. They already were. And the last fraction is 1/3. Sometimes we get a bit confused when we think, oh, this must be the biggest one. It's the biggest number. Remember what the denominator is showing you. It's showing you how many equal groups something has been split into. So the more groups, the less there is in each group. So do not think because you see a big number, it's the biggest fraction. A large denominator means that it's been split into a large number of groups. So each group is going to be smaller. A small denominator means it's been split into a smaller number. So each group is going to be bigger. Think pie. Small piece of pie, big piece of pie. Small piece, big piece. big piece, 1/3. 1/9 small piece. Big tummy, satisfied tummy. Big tummy, oh, I've eaten too much tummy. Oh, actually, that was a nice piece of cake. I can cope with that. So put these fractions in descending order for me, please, with the biggest fraction first and the smallest fraction last. The biggest fraction first and the smallest fraction last. Biggest first, smallest last. So the biggest piece of pie is 1/3. The next biggest is 1/6. The smallest. So biggest, next biggest, smallest. Full tummy feeling sick. Oops. Small tummy, big tummy feeling sick. Feeling a little bit sick but don't need anything else. Feeling very nice, thank you. That was just a perfect piece of pie. Okay. Let's look at this cake. There were 8 people at the party, and this is the way the cake was divided. Tell me about it. Tell me about it. There were 8 people at the party, and this is how the cake was divided. Tell me something about that. What have you got to say about that? What do you have to say about that? It's a beautiful cake, I must say. Well, you can't see it, can you? Because it's all in boxes. You don't know. It could be a yucky cake inside there. So you can't comment on the cake. But you can comment on, do the fraction police need to come? Has fairness been applied? Do the fraction police need to come? Has it been fair? Well, look who's come. Look who's come. Look who's on the scene. The fraction police are here. Oh, okay, officer, you're going to come out and give us a lesson. Okay, out the officer comes. 8 people. The correct fraction has not been chosen because this piece, this quarter, is much bigger than these 9ths. And whoever gets this piece, the 12th, is going to be crying like a little piggy, wee, 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 all the way home, because they only got a 12th, whereas these 5 people got a 9th, and yum yum for this person, they got a quarter. Fraction, please, exactly. 8 people. The fraction, please, has a question for you. The fraction officer has asked you, what fraction should this cake have been shared into? What fraction should this cake have been shared into? The fraction police asking you, what fraction should this cake have been shared into? Yes, exactly. 8 people. The cake should have been shared into 8ths. Right, the fraction police has said that they can see this sharing is in good hands. So they have now gone away back to the fraction police station because they can see that the fractions are in good hands. So that was lucky. Right, let's have a look at the other problem. Okay. So 2 different pieces of wood have had a fraction chopped off, and there are the pieces left. Okay. So they're exactly the same size. That top piece has had 5/6 chopped off, or that these are the pieces left. So that piece is 5/6 of what was left. And this piece, they're the same size, but this is 3/4 of what was left. Okay, so that's 3/4 of what was left. So a quarter was cut off. This is 5/6 of what was left. So 1/5 has been 1/6 has been cut off. Which piece of wood was longest to start with? Which piece of wood was longest to start with? Aha, fraction please, we have surrounded. We have you surrounded. Divide your cake into equal parts. Exactly, that is exactly what the fraction please would say. So which piece of wood was longer to start with? And explain your answers, please. Don't just guess and tell me. I want to know why. I will not accept any answers. Ooh, 3/4 was longer, I think. No, we haven't done a quiz yet. You have not missed a quiz. I don't want any I thinks. Give me some reasons. Give me some reasons. Come on. No I thinks. So the bit that's missing here, let's have a look. The bit that's missing there. Okay, well, let me just take that out. This is, let me write these on here. This is 5/6. So the bit that's missing is 1/6. This is 3/4. So the bit that's missing is 1/4. Now, seeing the bits that's missing, what can you say now? No, not equal. Seeing the bits that were chopped off, which of those fractions is bigger? Which of those fractions is bigger? 1/4 or 1/6? 1/4 or 1/6? Which is bigger? Which is bigger? 1/4 or 1/6? 1/4 or 1/6. Now we can look at our equivalence board, but do we need to? Which piece of pie would you rather? 1/4 or 1/6? Which is bigger? People who've written 1/6, think about bigger fractions. They have smaller denominator. Bigger fraction is more pie. Which bit is bigger? 1/6 or 1/4? Which bit is bigger? Pie. 1/4. Oh, no. I'm drawing 6 very quickly. Let me try again. 1/4 or 1/6. Which piece is bigger? Let me see the person who put 1/6 type in the correct answer. Yeah. Oh, thank you. More pie. Remember, the bigger the fraction, the smaller the denominator is. It's been split into less groups. So to do this, looking at that, you could think, oh, I could do equivalence there. Or you could say, well, if that is 5/6, 1/6 was cut off. If that is 3/4, 1/4 was cut off. So 1/4 is going to be longer than 1/6. More pie, less pie. More wood, less wood. 1/4 is more wood than 1/6. Okay? So, well done. Brain teasers. How are your brains hurting now? Have your brains been teased enough? Have your brains been teased enough? So I'm going to keep those equivalent cakes there because they're quite good to use in case we need to remember, which is bigger and which is less. So let's just do, with that in mind, let's just do some greater than, less than, using the maths that we know already. Okay, so let's have a look. What would we put in? What have I got here? 3/5 and 4/7. Is 3/5 greater than, equal, or less than 4/7? 3/5, 4/7. 3/5, 4/7. Now, when I try and think just what's obvious, and I think, okay, I would look at that and say, oh, where's a half? Where's a half feature then? Actually, I can't use that. I can't use it. So I've got to make them have a common denominator. Okay? I've got to make them have a common denominator. They're both prime numbers, so I'm not going to get them into multiples. I'm going to have to put them both over 35 and then see. So if I put them both over 35, because 5/7s are 35, okay, 5 goes into 35 7 times, 3 7s are 21. Okay, 7 goes into 35 5 times, 5 4s are 20. Look how near they are. I have to put them over a common denominator. Then I can see that 3/5 is just slightly bigger than 4/7, but I've got to put them over a common denominator. Okay, And because they're both prime numbers, I had to multiply. I couldn't make the numerators. Well, I could have said, let's make the numerators both 12 and then compare the bottom, but it was just as easy to look at the denominators. So 5/5 is bigger than 4/7, because when I made them into equivalent fractions, I can see that 21/35 was one more than 20/35. Okay, so I had to put them over a common denominator. Sometimes you can do it in other ways. Sometimes you just have to go for it. So let's have a look at another way. 4, another one, 4/5, 3/4. 4/5 and 3/4. 4/5 and 3/4. I'm glad this is really helping you. I'm really glad. Okay, so I'm going to say I'm going to put those over a common denominator. Okay, because I can do 2/3. Well, not really thirds there or quarters there. It doesn't really help, does it? So let's have a look. What's the lowest common multiple? Well, if I go up in fives, 5, and I see if 4 goes into these, 5, no, 10, no, 15, no, 20, okay, 20. The lowest common multiple is 20. So I'm going to put them both over 20. I'm going to make them both 20ths, okay? So 4/5, if I make that into 20ths, what did I have to do to the 5 to make it 20ths? I had to multiply by 4. 4 5s are 20. 4 4s are 16. Okay, so 4/5 is 16/20. Let's have a look. 3/4. Let's see what that equals to 20ths. What do I have to do to 4 to make it 20? 5 4s are 20. Okay, so I'm multiplying by 5. I've got to do the same to the top. Got to do the same to the top. 5 3s are 15. Now I can see them both as 20ths. Okay? And again, there's not a lot in it, but 4/5 is slightly bigger. It's 16/20, whereas that is 15/20. Okay, so that one is bigger. That one is bigger. Okay, so let's have a look at another one. Let's have a look at another one. What other ones have I got here? 3/4 and 7/10. 3/4 and 7/10. 3/4 and 7/10. Actually, I would use some other math to work this out. I would use decimals to work this out. I wouldn't have to put this over a common denominator myself. I could look and work out a different way. Because it's over 10, I would know that 3/4 of the way to 10 is 7.5. So I could make that a decimal and say that's 0.75. So I know that 3/4 would be 7.5 tenths, whereas, so that makes it more. I would do that. But if I couldn't do that and I wanted to put them over a common denominator, I'd say, okay, let me go through my multiples of 4 until I can see one that's in the 10 family. 4, no. 8, no. 12, no. 16, no. 20. Oh, okay. So the lowest common multiple is 20. Let's make them both into 20ths, okay? Let's make them both into 20ths, and then we can compare them. So if I'm going to make this into 20ths, what did I have to do to 4 to make it 20? I had to multiply by 5. So I've got to do the same to the top. So 15. So 3/4, which we know, equivalents, you could simplify 15/20 down to 3/4. Let's have a look and make 7/10 into 20ths. Okay. Well, I've got a double 10 to make it 20. Got to do exactly the same to the top. So 14. Oops, can you see? Come over. So 14. So we can see that 3/4 is bigger than 7/10, because that's 15/20, and that's 14/20. So 3/4 is bigger than 7/10. Okay. So some we have to do a common denominator, some we can think about others. Oh, I hope we're awake for this one. I hope we're awake for this one. 6/10 and 6/12. Now the fraction police are going to come if anybody doesn't remember what we've done already. The fraction police are primed and ready to come. Tell me this one and tell me how you know. Woo, 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 woo. They're waiting. Tell me this one and tell me how you know. Think cake. Think cake. Think cake. Think cake. Which would you rather have? Think cake. Think cake. Which is bigger? Are 6/10 bigger than 6/12? Or are they smaller or are they equal? Think cake. The numerators are the same. The numerators are the same. Thank you. Thank you. Hey, hey, hey. Thank you. Thank you. Thank you. Thank you. Tenths are bigger than twelfths. You'd rather have a tenth of a cake than a twelfth of a cake. So you'd rather have 6/10 than 6/12. Some people also said, oh, I can see that's a half, and a half of the tenths would be 5/10. So I can see that that's big, that's bigger because that's more than a half, that's a half. But also you could think tenths are bigger than twelfths. So I would rather have 6/10 than 6/12. Okay, but you can also say that's a half, that's more than a half because 5/10 are a half. Thank you for using the maths you know already. Did not need to put that over denominators. Okay, here's one. Here's one. Let's see how awake you are. Here's one. Here's one. Here's one. Have a look at that one then. We will do the interactive quiz next. After this one, we will do a quiz. Okay? We will do a quiz after this one. Let's just look at this one to make sure we've got the maths locked down. We do not need to worry about these in comparing because we know that 2 wholes is equal to 2 wholes. Okay? So we're just looking at these. We haven't got the same numerator. We can't compare. So we've got to make them the same denominator. Let's go through our multiples of 5 until we get to a multiple of 8. 5, 10, no. 15, no. 20, no. 25, no. 30, no. 35, no. 40, yes. So we've got to make them both over 40. So they've both got to go over 40 so we can compare them. 8 5s are 40, 8 2s are 16. 5 8s are 40, 5 3s are 15. So once again, tiny difference. That one is bigger. Okay, so use what we have just done to help you do the quiz. Naggy children, naggy children. There we go. Quiz, off you go. Use what we have just done to help you do the quiz. Okay, so remember, move me out of the way to help you scroll down. Move me out of the way to help you scroll down. Okay, so the first one is simplify 4 and 9/12. Simplify 4 and 9/12. Look very carefully at the numbers because it's quite hard to distinguish between the whole number and the fraction. Okay, so make sure you're looking carefully. 4 and 9/12. Okay, so the 4 is going to stay the same. You're simplifying 9/12. 9/12. Now you remember, to simplify, you have to share the top and the bottom by the same number. If it's 2/3, that means you have divided 9 by 2. And that won't come out. Okay, number 2 is causing a problem. Aha! So, descend in order. Which one would come next? In descend in order, which one would come next? Have I not put a pattern in there? Ah. I entered a pattern in and it's gone. Okay, you can't do number 2 because the pattern I entered in didn't come up on the quiz, so you can't do number 2. Sorry, we'll do that one in a moment. I will put the questions on the board for you because I've got them here. Okay, I'm going to write the question number 2 on the board so you can have a go, okay? These are the fractions that should have been in there, but they did not come out. I do not know why. Which, in descend in order, which of those fractions would come next? The 2 fractions that should have been in the question are 1 2/3, 4/3, then which of those fractions would come next? Okay, descend in order is biggest to smallest. Descending, coming down the mountain. Okay, coming down the mountain, descending from the top to the bottom. So for question 2, I have put the fractions on the board. Okay, so 1 2/3, 4/3, which would be the next fraction in descend in order? So it has to be smaller than 4/3. Oh my goodness me, the third one doesn't make sense either. What's gone wrong here? Solve. 4 3/5 take away 4/5. 4 3/5 take away 4/5. It does make sense. 4 3/5 take away 4/5. Okay. I'd like it as a fraction, please, not a decimal. It's 4 whole ones and 3/5 take away 4/5. It's a takeaway. It's a takeaway. Okay, we'll go through all of these. We go through all of these. I haven't shared your results yet. That's why you can't see them. I'm going to end the voting, and then you'll be able to see your results. Okay. I'm going to end the voting, and you'll be able to see your results. Okay. We will be teaching English, just not at the moment. We will be doing English and science and other subjects as well. At the moment, we've just started off with maths. Okay, let's go through these questions because they caused a little bit of a pickle, I think. So let's go through them together. Let's go through it. It didn't help that I didn't have the questions on. Let's look at question number 1. Question number 1 is we had to, let me just, I'll put number 1 in red at the top. We had to simplify 4 9/12. We had to simplify 4 9/12. Now, people still get confused about which is a quarter and which is a third. Okay, so some people said it was 3/4, some people said it was 2/3. Okay, now if you're going to simplify, you have to divide the bottom and the top by exactly the same. So if you're going to say, oh, well, actually, 3 can go into both of those. 4 3s are 12. 3 3s are 9. Some of you said it was 2/3. So you divided the bottom by 3. By 4, and then you divided the top by 4. Well, that can't happen, can it? Because 9 divided by 4 is 2.25. 3/4. And so the answer is 4 3/4. People get confused about thirds and quarters when they're thinking about 12ths. Quarters, 4 equal groups, 3 in each group. Thirds, 3 equal groups, 4 in each group. Okay, so just be clear that you are doing the same with the bottom as you are doing with the top. So the next one said descend in order, 1 2/3, 4/3, and you had, these were your choices, 1 1/4, 6/4, and 2 1/3. Now they're getting smaller. 1 2/3, 4/3, which is the same as 1 1/3, isn't it? That's the same as 1 1/3. 4/3, make a whole one, you've got one left over. So you know it can't be 2 1/2 because that's bigger. So that's got to go. Okay. Well, 6/4, let's simplify that straight away. It's 1 1/2. Yeah. That's 1 1/3. Which is the smaller fraction, a third or a half? You'd rather have half the cake than a third. So you know it can't be 1 1/2. A quarter is smaller than a third. So the next size fraction down is 1 1/4. Okay, pieces of pie. Simplify, make things easier for yourself. Simplify, okay, simplify. So let's now have a look at that last one. Let's have a look at that last one. Let's have a look at that last one. Can you see it? Yes, it's there. So we've got, oh, that's a little, lost our 3 there. 4 3/5, take away 4/5. Okay, 4 3/5, take away 4/5. Now, you can't take 4/5 away from 3/5. You haven't got enough fifths. You haven't got enough fifths. So you need to have some, you've got loads of fifths over here. If each whole one is 5/5, you've got 4 lots of 5. You've got 20/5 over here. But you don't need to use all of them. So you can just use one. So if you say, well, we've got 3 holes, and I'm going to take 5/5 and add it to there. 5/5 and 3/5. So you've got 8/5. And now you're going to take away 4/5. Now that's much easier, isn't it? So you've got 3 and 4/5. Okay. You didn't have enough there. You didn't have enough fifths there. So you had to exchange a whole one. You use the whole, exactly. Exchange a whole one. Okay, so you've got 3 whole ones left. A whole one is 5/5. So you've got 3 and 5/5. You've got 8/5. And then you can take away 4/5 from 8/5. Okay, you can then take that away. Yeah. So that caused a few little prickly problems. So let's have a look at a few of those problems. Let's get a bit better at not having prickliness. Yes, let's get a bit better. So let's just look at working with fractions so we get a little bit more confident with the add-ins and the takings away and the using a whole one when you haven't got enough. Okay, so let's drop the screen down and do a little bit more problem work with fractions. So here's a part whole model. Here's a part whole model. What needs to go in the blank? What needs to go in here? Here's a part whole model. What needs to go in here? Yeah. So we've got 2/4 equals 1 3/4. What's going to go in there? What's got to go in there? Okay. Okay, can you not see? Move that in. What needs to go in the in the empty box? So you could say, well, let's do a subtraction, couldn't you? You could say, let's do a subtraction. So we've got 1, we've got 2 and 1/4. Take away 1 and 3/4. We want to know what goes in there, or what's got to be added to that to make it that. What's got to be added to that to make it that? That's what we need to know, isn't it? What's got to be added to that to make it that? Yeah. Now I would be able to look at this and say, oh, well, 3/4 just needs 1 more to make it 2. Because if you add this 3/4, if you add 1 more to it, then you get a whole 1. And then you just need to put 1 more on. So it's 2/4. Or, what's the simplified version? 2/4 or 1/2, isn't it? 2/4 or 1/2 in there. If you are going to do this as a subtraction, okay, like we did before, then you can't take 3/4 away from 1/4, can you? So you need to do that whole, exchange that whole one again. So, okay, we got lots of quarters tied up here. 2 cakes would give us 8/4. 1 cake would give us 4/4. 2 cakes would give us 8/4. So let's take 4 of those. So we can add 4/4 and 1/4 because I've taken 4 from there. So that equals 5/4. Now I can take away the 3/4, and that gives me 2/4. So I've got the 1 there, still got the 1, yeah. So and that's what we've got there, isn't it? 1 3/4 plus 2/4 equals 2 1/4. And we can simplify 2/4 to 1/2. Yeah. So I could think about that on the number line. Let's have a little look what other ones we've got here. What other part whole models we've got. Oh, how about this one? Let's get that better in the screen. Right, so we've got 5 6/8. We've got 1 1/8 over there. What's going to be in there? What's going to be in there? What do we have to add to? So 1 1/8 plus what equals 5 6/8? What's got to go in there? What's got to go in there? Can you still not see? You still not see? What's got to go in there for the whole part model? What's got to go in there? What's got to go in there? Yeah, well, we can see, can't we? Look, 6/8, 1/8. Well, we know there's 5/8. And actually, 4 and 1, we know it's 4 and 5/8. Yeah, 4. Don't forget the 4. The 4 whole ones, yeah? It's not just the 5/8. It's the 4. Yep. So we're going to have 4 in there and 5/8. Yeah, 4 and 5/8 have got to go in there to make that one. So let's have a look at the last one. What have we got down here? What's going to go into this one? What's going to go into this one? What's got to go into this one? This is the last one now of the part whole model. So we've got 3 7/12. We've got 3 7/12 plus 1 3/12 equals what? what's got to go into the empty circle. So we've got the two parts. What's the whole? We've got the two parts. What's the whole? We've got the two parts. What's the whole? So 3 and 7/12 plus 1 and 3/12. Yep, we can add the wholes together. So we know we've got 4, 7, and 3 is 10. 10/12. Ooh, what can we do with 10/12? What can we do with 10/12? Remember, the fraction piece will come if we're going to have any fractions that are complicated. Okay, the fraction piece, I can hear them coming. All right, officer, we're on to it. Give us a moment. Give us a moment. Give us a moment. How can we simplify that? How can we simplify it? Yeah, okay, we can divide that by 2, gives us 5. Divide that by 2, gives us 6. 4 and 5/6. We can't simplify that anymore. Fraction, please, you may go away. We have sorted it. Thank you very much. We have sorted it. Thank you very much. Thank you very much. That 5th one caused a few little pickles when we were in the quiz. Well, let's see, it'll come back in a minute. It's just focused on my hand. Come on, back in. Let's just bring that down again. Sometimes it focuses on my hand and then it doesn't want to focus. That's it, on what's there. Just go up a little bit so you can see a bit more of it. There we are. Okay, so here we have a number line. Okay, a number line that goes 2, 3, 4, 5. And in between, you've got intervals of fifths. Okay, 1, 2, 3, 4, 5 fifths. 3 and 1, 2, 3, 4, 5 fifths, which is 4. 4 and 1, 2, 3, 4, 5 fifths, which is 5. Okay, so let's use that number line to solve that equation. Is it possible to have a decimal fraction? You don't usually mix fractions and decimals. You would normally make the whole thing. We are going to have another quiz, yes. So let's use the number line to help us solve this problem. The next quiz is in about 3 minutes. Let's use this number line to help solve this problem. Okay, so we're starting off with 3 and 4 fifths. 1, 2, 3, 4. And we have to take away 3 fifths. So that's where we are, and we take back 3 fifths. 1, 2, 3. So the answer is 3 and 1/5. Exactly. Okay, so the number line can help you. Let's do the next one. 4 and 1/5, take away 4 fifths. 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 Okay, so we've got 4 and 1/5. Let's go up to 4 and 1/5. There's 4 and there's 1/5. And we're taking away 4 fifths. So let's take 4 fifths jumps back. 1/5, 2 fifths, 3 fifths, 4 fifths. So the answer is 3 and 2 fifths. 3 and 2 fifths. Okay, let's do the last one. So the last one is 3 and 2 fifths, take away 4 fifths. 3 and 2 fifths, take away 4 fifths. Three and 2 fifths, take away 4 fifths. Oh, just make sure you can see the number line to help you jump. And you can always draw your own number lines when you have to do any question like this in a test, at school, at home. Just draw your own number line with the equal divisions for whatever fractions. If you were doing 12ths, 10ths, just draw those steps in, remembering that 12 twelfths would be the next whole number. So let's have a look where we were. We were on 3 2/5, 1/5, 2/5. And we had to take away 4/5. So 4/5 jump back. 1/5, 2/5, 3/5, 4/5. So the answer is 2 3/5. 2 3/5. 2 3/5. Okay, let's do a quiz. The quiz at the end, remember, is to help you have some idea about whether joining the earlier lesson would help you build confidence as well. So let's look at the quiz. Are we all ready? Here we go. Quiz away. Off you go. Okay, quiz number 2. Off you go. Remember to look carefully, okay? Sometimes the quiz does not show the fractions very easily. So look carefully at what those numbers are, okay? Look carefully at what those numbers are. You're going to need a pen and paper to write these down. I'm going to need a pen and paper to write these down. The sound of brains working. I can hear it. The sound of brains working. Okay. So you've got a nice little adding up one to start. Taking away one for the second one. And an adding and taking away for the third one. Okay. And an adding and taking away for the third one. And careful working. I will write them up on the board while you're doing that so that we can go through them. Okay. I'm so nervous. Why are you so nervous? Don't be nervous. Do you know what? You're the only person who's going to see it. So nobody else will know what you scored and what you did not. Okay? Nobody else will know. So nobody needs to be worried. That's the really big benefit of joining these lessons, is that you can be who you are and nobody else knows. Okay? So if you made a mistake, nobody knows. If you join the earlier lessons and it's a curriculum that's younger than your class, it's not like being taken out of the class to go for an intervention or the teacher coming over and saying, oh, I'll help you. You can really relax and have a chance to go back in time and have a chance to see the curriculum that you learned in earlier years again. Now that you're a bit older, you get the chance to see it again. Really helps to firm that understanding. Nobody need to be worried. There is no bad score. There are just indications of where you need some more little help and practice. Okay, so we're going to go through them together. Just going to give a few more seconds and then we will go through. Okay, Rexy's coming over now because he thinks you're worried and he needs to say to you, don't be worried. The reason you are here is so you can really practice your maths and not worry about anything. Okay, so a little message from Rexy there. Okay, yeah, exactly. Let's be positive. And actually, if you have made a mistake, then let's say, okay, that was really helpful because it showed me where I need more practice and I can get more practice. So that's absolutely fine. Okay, I'm going to end voting and I'm going to share results. Okay, so just so you can see what you got and where you are confident and where you might need a little bit more support. Okay, so there's the results and we're going to go through them together so that you do not need to worry if you were needing a bit more support, and that's exactly why we are here. Okay, so I'm going to close that down. Well, you know the ones you got wrong because we're going to go through them together now, and then you can think, oh, I didn't put that answer. Okay, yeah, right, so let's have a look. These are the questions that were on the quiz. The first one was 3 21s plus 2 7s plus 1. Now, I did put that there as a tricky question to make sure that people were realizing that was a whole one which cannot be forgotten. Okay, so let's have a look. We need to put these over a common denominator. We know our tables. We can see that 21 is in the 7 times table. So straight away, we can put them over 21, okay? So we put them over 21. Remember, we've still got that whole one. We can't forget about that one. Okay, maybe some people forgot about that one. We've still got a whole one there. So 21, I didn't have to change anything. So that still remains as 3 21s. 7, 3 21s, 3 7s are 21. So I had to multiply by 3. So let's do the same over the top. 3 2s is 6. So 3 plus 6 is 9. So the answer is 1 and 9 21s. I cannot simplify 9 21s anymore. They do not have a common factor, 9 21s. Okay, let me just move that over a little bit so you can see it. So the answer to the first one was 1 and 9 21s. Okay, 1 and 9 21s. That was the answer, 1 and 9 21s. I think some of you forgot about that whole one. Okay, so the first one was 1 and 9 21s. What I will do is I will put the quiz back on again so you can have a look again. So make a note of what the correct answer was. I'll put the quiz back up so people who didn't get them all right can have another little look and say, ah, right, okay. All right. So the second question, question number 2, was 4 and 3/5 take away 9/10. Now, we're going to put these over a common denominator. We can see that 5 and 10 are in the same family. Okay, 10 is a multiple of 5. So straight away, we know we can use the 10s. So we've still got the 4, and we're going to put them over 10. Okay, we can't lose the 4. So to make 5 10, I had to multiply by 2. So I've got to do the same to the top. 2 3s are 6. To make 10 10, didn't have to do anything. So I don't do anything to the top. Now I'm in a situation of 4 whole ones with 6 take away 9. Now I can't do that, can I? Without going into negative numbers. But I've got all the fractions caught up in this whole one. 4 whole ones. Well, that's 40 tenths. If I had 4 cakes in tenths, I'd have 40 tenths. So I can take one of those away and I can give it to this one here. Okay, because that's the one that's carrying the whole numbers. So 4 and 6 tenths is the same as 3 and 16 tenths. So now I've got 16 take away 9. 16 take away 9 is 7. So the answer is 3 and 7 tenths. Okay, 3, oops, you've lost it again. There we go. 3 and 7 tenths is the answer. Okay, so putting them over the common denominator, if I need to exchange one of the whole ones to release more fractions, I can do that. Right. Then we had this last one. Oops, that's two. Last one is here. Make sure I don't take this one away. Then we had this last one, which was a combination of an addition and a subtraction. So we know the order we do things in. Addition comes first. Okay, so let's look at this part of it first. Let's look at that part first. Okay, we break it up. So we're going to do that part first. 3 2/5 plus 4 7/10. Look, nice and easy, nice and easy. Just move that up a little bit so you can see. Okay, nice and easy. Yeah, same family, same family. So we know that the lowest common multiple is going to be 10. So we've got, let's add our whole ones together. Adding up, we don't have to exchange, it's adding. So 3 and 4 equals 7. Okay? Then we're going to do the fractions. We put them over 10. Double 5 is 10, double 2 is 4. Didn't have to do anything to make it tenths, it's still the same. So now I've got 11/10, 7 and 11/10, because 4 and 7 is 11. Is that the simplest way? Is that the simplest way? I can make another whole one there. I've got 11/10. I've got a whole cake and one bit left over. So I make that into 8 and 1/10. Okay. Now I've got 8 and 1/10. Is that what that's what that comes to? Take away 4 and 2/20. Okay. So let's do that. 8 and 1/10. Take away 4 and 2/20. Same family. The lowest common multiple is going to be 20. Okay, it's a multiple of 10. So let's do the whole numbers. 8 take away 4 is 4. Yeah. And then the fractions. Put it over 20. To get 10 to 20, I've had to double it. So double the top. To get 20 to 20, I did nothing. Oh, 2 take away 2 is 0. Oh, so it's 4 and 0/20. Oh, sorry, equal sign. So the answer is 4. All that fraction work, and the answer is a whole number. Now I've gone through that. Let me put the quiz back up. Now I've gone through that. Let me put the quiz back up. For those of you who did not get all of them right, just go through the quiz again and have a go again and see if you can improve your score this time. If you did get them all right, then if you want to do the quiz again, of course you can, but you don't really need to. But those of you who didn't, just go through again. And now that we've gone through, see if you can get a better score this time. See if you can get a better score this time. Okay. While the people are doing the quiz, let's take this off because I don't want you to get a better score because you can just copy the answer here. I want you to make more sense. While we're doing that, the rest of you can have a look at this and tell me if you agree. Tell me if you agree. If you're not doing the quiz, can you have a little look at this and tell me if you agree. Okay, people doing the quiz, let me know when you finished and let me know how you got on this time. If you're not doing the quiz, have a little look at this problem. We're going to finish in about 2 minutes. Okay. I'm going to finish about 2 minutes. Just a little bit longer because I wanted people to have another go at doing the quiz. And if you have finished, can you have a little look at this and see if what your thoughts are? If you finish the quiz, tell me what your thoughts are here. Do you agree with this solving of this equation. Do you agree? I'm glad that people have got it now. I'm glad that I've had that little bit of feedback. Yeah, I got that better now. Okay, and we're just asking, do you agree with this? I'm just going to, yes, people disagree. Tell me why you disagree. Okay, don't worry if you accidentally click submit. Don't worry. You know whether it was better for you or not. Tell me why you disagree. Tell me why. What did they do wrong? I'm just going to end the voting to see if anybody is still doing the quiz. I can just see the circles go up if people are still working on it. No movement. I'm going to end voting. I'm going to share results now so you can see if you got a better score this time. See if you got a better score this time. Okay, so hopefully that quiz was better this time. Let's go back on here. The last question before we finish. People are saying no, they don't agree. What have they done wrong? Okay, well done. Well done. I'm glad you're pleased. Okay, when you add in fractions, you're not just adding the denominators and the numerators, are you? You have to make them have a common denominator. So what they have done here is said 5 and 15 is 20, 3 and 1 is 4. No, that is not what you do. You have to make them have a common denominator. So 15 is a multiple of 5, so the common denominator we can straight away see will be 15. 3 5s are 15, 3 3s are 9. 15, you don't have to do anything to it, so that stays the same. So the answer is actually 10 15ths, which we know can be simplified to 2/3. So if you were going to do that, you'd end up with having much less cake because you could have got 2/3 of it and you would have only ended up with 1/5. So make sure if somebody says, do you want this and this, you know how to add your fractions. Well done. You have worked very hard today. Very, very hard. And there's some tricky work in today and you really did well. You really, really did well. So we're going to battle on with fractions. Some of you have said, yeah, this is really, really helping me. So that's really good. Tell me what you'd like more of next week. Tell me what you'd like more of, please. Thank you, thank you, thank you. What would you like more of? What was good? What would you like more of? I know the quizzes, but 2 quizzes is enough. Otherwise, you don't get the teaching in. Okay, tell me some more. What would you like more? Thank you very much. I'm really glad you told me it's helping your maths. That's really important. If you do want to jump onto the earlier lessons, of course, please do. The scales, did you like the number line work? Did that really help? I felt that helped a lot as well, using the number lines. Oh, how many zeros have you got there? I think you got a million quizzes. Bye-bye, everybody. Have a lovely week. Oh, more explaining for the questions in case some of us have a hard time understanding the questions. Yeah. So was that the quizzes you mean? Just going through those quizzes. Was it quite helpful to do the quiz again then once you'd had the explanation? It felt like it was. Okay. And the number line work with the fractions, I think that really helped people as well. Okay, good. All right, thank you for that. I felt that was a useful thing to do as well because there's some tricky questions there. Okay, well done, everybody. I will see you next week. Okay. Make sure that you join the earlier lessons as well if you're feeling a little bit anxious. Okay. Times tables. Well, the times tables, we are using times tables all the time as in fractions. So you are using your times tables all the time to solve the fractions problems. We're going to do some money work next week as well. Money, 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 money. Well done, everybody. I will see you next week. You take care. Bye-bye.